With the rise in temperature, Young's modulus of elasticity, how it changes, how temperature and Young's modulus they are related. So Young's modulus is the measure of stiffness of material. So mathematically defined as stress by strain. So whose force per unit area strain is this. So once material is heated, how its length changes, L2 is equal to L1 into 1 plus alpha delta. Alpha is coefficient of linear expansion. L1 alpha delta. Change in length delta L is L alpha delta T. So once temperature is raised, length will increase. So delta T increases, delta L increases. Once delta L increases, Y is inversely proportional to delta L, Y decreases. Here R is radius of the earth due to acceleration due to gravity on the surface of the earth. That is one information. Length of second pendulum. Seconds pendulum at h is equal to, he is asking, from the surface of the earth. Seconds pendulum means time period is 2 seconds everywhere. So here, whether it is on the surface or above the surface, no change in the time period. So once since G changes, L also must change to make time period as 2 seconds. So with respect to height, how G changes like this. So 1 plus 2 R by R, which is, so time period will be 2 pi root L by G dash. G L dash, let us say, G dash is G by 9. It is 3 times 2 pi root L dash by G. So time period is 2 seconds. Root L dash by G is pi square. So we get here 6 pi root L dash by pi. Root L dash is 1/3. So L dash becomes 1 by 9 meters. So in the given circuit, here it is a problem related to Jenner diode. So here, this is supplied voltage. This is breakdown voltage. So Jenner diode, so especially it works in both the directions, forward as well as reverse. Particularly, so this is utilized to uh, for voltage fluctuations. So the voltage drop across Zener diode will be 5 volts irrespective of the supplied voltage. So without changing voltage, current flows through it. And what he is asking here, value of the resistance Rs. So how do we get resistance? How much current passes through it? Once we can measure, and potential difference across this we can measure, we can find the resistance. Here it is, current through AB will be, he given that power rating of Zener diode. Power rating is Zener voltage into current. I here is P by Vz, 10 milliwatt by 5, that is 2 milliwatt. This much current is flowing through this. And what is the potential difference across AB? Is same as potential difference across CD, which is how much? This is 5 volts, which is equal to I into RL. Here RL value is given as 1 kilo ohm. So from this, here I will be 5 by 1 kilo ohm, that is 5 into 10 power minus 3 ohms, amperes, 5 milliamperes. Then total current will be I plus I, 2 milliampere plus 5 milliamperes, which is, so through this resistance 7 milliamperes current is flowing. So potential here it is, supplied voltage is 8 volts, potential drop here is 5 volts. Then potential difference across DE will be 8 minus 5, which is 3 volts, which is I total into Rs. So Rs will be 3 by 7, right? That is into 10 power minus 3 ohms. Seems to be answer is not there. So bonus mark. Here identical capacitor have the same capacitance. So this is capacitor. So here it is connected to a battery. Uh, then charge stored here will be CD. So another capacitor, same capacitor is connected to another battery whose, that is having potential 2V. Charge to a potential 2V means here charge stored will be C into 2V. So the negative ends of both are connected together. So here this is positive and let us say this is another capacitor. Positive ends are connected, at the same time negative ends are connected. So such arrangement is connecting capacitors in parallel. So here charge is CV, here charge is 2CV. So charge is conserved, Q1 plus Q2 will be 3CV. Since here one, this is connected to, it is charged 2 volt, more charge is there. Once they are connected in parallel, potential difference across AB must be equal to potential difference across CD. So that is uh, B dash equal to Q dash by C, which is equal to, here Q dash is the new charge on this capacitor, and Q double dash, actually this is right C. Since potential difference is same, Q dash will be Q double dash. That means same charge gets deposited on both capacitors. So Q1 plus Q2 becomes 2Q, which here Q will be Q1 plus Q2 by 2, which is 3CV by 2. Now, what is the loss of energy in the combined system? So energy has a formula, half CV square or Q square by 2C. Originally Q has CV, now it is 3CV by 2 by 2C. Originally 2CV, now it is 3CV by 2 whole square by 2C, which is CV square by 8 plus CV square by 8. That is loss of energy is 1/4 CV square. Here 2 moles of monatomic gas is mixed with 6 moles of diatomic gas. Gamma of mixture at constant volume N1 CV1 plus N2 CV2 by N1 plus He given 2 moles of monatomic gas, 6 moles of gas. For monoatomic gas, degrees of freedom 3. Gamma will be 1 plus 2 by 3, that is 5 by 3. For diatomic gas, gamma here is 1 plus 2 by 5 degrees of freedom, 7 by 5. CV we will calculate R by gamma minus 1, that is 3 by, for diatomic gas, R by gamma minus 1, gamma here is this, gamma mixture at constant volume is 2 into CV, 3R by 2 plus 6 into CV2, 5R by 2 by N1 plus N2. 15 plus 3, 18R by 8, 9R by 4. That is gamma of the mixture. So here a ball of mass here a ball of mass 0.5 kg is attached to a string of length 50 centimeters. So the ball is rotated in a horizontal circle. The maximum tension that the string can bear once it is rotated in a horizontal circle. So this bob is, let us say, right. So tension T acts here, it is sine theta. It is theta, it is T cos theta. So tension component on this centrifugal force acts. So T sine theta is mr omega square. Great. And this is length of the string. It is radius. Sine theta here is r by l. So t sine theta is m. R is L sine theta omega square. So the maximum tension it is ml omega square, which he given it as 400 newtons. Mass is 0.5 kg. L is half. Omega square is 400. So omega square is 800 by zero point 0.5. So we get 1600. Omega is 40 radians per second. So here it is parallel plate capacitor has a capacitance 200 picofarads. 200 into 10 power minus 12 farads. It is connected to capacitor is connected to 2000 volt AC supply. Angular frequency is 300 radian per second. So RMS value of conduction current and displacement current. Here it is conduction current between the plates, displacement current. So here, how do we calculate conduction current? That is V by Hc. So that is 230 by 1 by omega c. 230 into omega, he given it as 300 radians. It is 200 into 10 power minus 12. 23 into 6, 138. For 10 power minus 7, which is 13.8 microamperes. So here displacement current is same as conduction current, which is epsilon naught d phi E by dt. Phi is electrical flux, which is by Gauss law it is Q by epsilon naught. D by dt of Q by epsilon naught get cancelled. So IC and ID both are same. So here it is 13.8. Both are 13.8 microamperes. The pressure and volume of ideal gas equation is not, it is fourth option is that 13.8 microamperes. The pressure and volume of ideal gas is related by PV power 3 by 2 is constant. PV power x equal to constant is polytropic process. Work done in polytropic process, it is similar to adiabatic work done in polytropic process is P2 V2 minus P1 V1 by 1 minus gamma. So here gamma is 3 by 2, 1 minus gamma will be minus half. So which implies 2 times P1 V1 minus V2. There is work done by the gas. Here galvanometer has a resistance 50 ohms and allows maximum current of 5 milliamperes. Galvanometer is very sensitive, so through this only 5 ampere current is flowing, 5 milliamperes. In a circuit across resistance, suppose potential difference happens to be 3 volts, with the small current and small resistance of galvanometer, we can't measure higher potential differences across the electrical components. So then what we have to do is we should connect resistance in series with the galvanometer. Your galvanometer has a resistance series. Effective resistance will be more, then potential difference becomes I into G plus R. We can measure higher potential differences across electrical components. So this is galvanometer. By adding it, now it becomes this arrangement becomes a voltmeter. So here galvanometer resistance is given 50 and I he given it as 5 milliamperes. We have to measure up to 100 volts. So what will be the resistance which we have to connect? Is 20,000. Resistance becomes minus 50, 19,950 ohms. That is has to be connected in series to measure higher potential difference. Here it is, according to de Broglie, matter behaves both like a particle and wave. Wavelength, here lambda is equal to h by p, so which is h by mv. Now what he is asking, ratio of velocity of proton, which velocity of proton, its constant mass of proton by velocity of alpha particle m alpha lambda alpha. So here it is Vp by V alpha is h by m alpha lambda alpha. So mass of alpha particle 4 units. Here mass of proton and here lambda of alpha particle 2 lambda. So well a wavelength of proton. So the ratio is 8:2. Here 10 divisions of main scale of vernier caliper coincide with 11 divisions of, it is 11 divisions of vernier calipers coincides with 10 divisions of main scale. So one division of vernier calipers, 10 by 11 divisions of main scale. So least count is one unit of male scale division minus, that is 1 minus 10 by 11 of main scale division. And main scale division is 5 units. So the vernier constant or least count is 5 by 11. In LCR circuit, the capacitance is changed. So here, to keep the resonance frequency unchanged. So capacitor and inductor are in resonance if omega L is equal to 1 by omega C. So that means their phase difference is 180 degrees. They are in resonance. Omega square here is, so once capacitance here, to keep resonance frequency unchanged. So that means omega is angular frequency. So to keep resonance frequency unchanged, the new inductance, once capacitor is changed to 4C, inductance must be changed so that omega dash will be equal to omega. 1 by L1 will be L1 to see here, which is omega. Right. 2 root here omega is nothing but 1 by root LC, which you can cancel. 1 by 2 root L1 is 1 by root L. 1 by 4 L1 is, so which is L1 is L by 4. So that means originally L new is this. That means it reduces by 3 L by 4. The radius is measured, the percentage error in resistivity. R is equal to rho L by A, where rho is resistivity, RA by L, R into pi R square by L. So here percentage error in resistivity is delta rho by rho into 100, taking logarithms and differentiating delta R by R into 100, 2 times delta R by R into 100. Actually here maximum error we will take instead of minus plus 2 delta L by L into 100. Delta L by L into 100. So here delta R by R, change in resistance is 10 ohms. Original resistance is this. Radius 0.05 by 0.35 into 100. Length 0.2 by 15 into 100. 100 by 7. So it's 4 by 3. 100 plus 200 by 7. 7 is 14. 60. 47 5s, again it is 1.33. Roughly it is 38 plus 1, 39.9%. So here angular impulse is equal to, in place of actual impulse is force into time, we have 2 into t, right? Which is nothing but is I omega 2 minus omega 1. Here I here is mr square into omega is 2 pi by t. So ml square t power minus 1. A simple pendulum of length 1 meter has a wooden bob of mass 1 kg. It is struck by a bullet of mass 0.10 power minus 2 kg, who is moving with a speed. So the bullet get embedded into the bob, the height to which the bob rises. So height at which once after embedding both move together and rises by height h. Here, just before hitting, just before hitting wooden bob, momentum of the system. System means here bob plus bullet. Bob is at rest. Bullet is moving with velocity 2 into 10 power 2. Momentum of the. After hitting, they embedded more like a single object whose mass is this. So get cancelled. M here is mass of bullet is 10 power minus 2 into V, which is equal. It's very smaller quantity, 1.01. It's almost 2 meter per second. With that velocity, this wooden bob and plus bullet moves. So that is what it has. It has only kinetic energy at this point. When it rises to the maximum height, the total energy is converted to potential energy. H here is V square by H. So 4 by 2 into G, it is 0.4 meters.